Maintenance directors allocate millions in capital based on CMMS reports. But the software driving those operational decisions is often compromised from the inside out. A high-level metric like 98% preventative maintenance compliance looks flawless on an executive dashboard. It signals stability and rigorous oversight. But look closer. Beneath that aggregate number, the actual database tells a different story. Required fields are left blank, required tasks are manually bypassed, and thousands of specific component failures are simply logged as miscellaneous. This is silent decay. When the rules dictating how data enters the system are weak, flawed inputs bypass the front door daily, quietly eroding the reliability of the entire CMMS over time. Attempting to fix this by exporting logs to a spreadsheet and cleaning them up retroactively is a failure in governance. It traps teams in an endless cycle of reactive firefighting. To establish reliable asset management, organizations have to abandon that reactive cycle. The solution requires a zero-trust data architecture. Trustworthy systems rely on a bimodal defense matrix. They require strict preventative controls at the precise point of data creation, paired with diagnostic condition monitoring throughout the data's lifecycle. We start by constructing the first layer of this architecture, the gateway. These are the data entry rules. They are rigid, predefined standards that dictate the exact format information must take before the software will accept it. The primary purpose of this gate is absolute control. It acts as a physical barrier to stop garbage data at the door, forcing strict structural consistency across all crews, shifts, and global sites. We execute this through specific mechanisms. Mandatory fields must be filled. Formats are restricted to numerical inputs. Hard logic checks validate the data in real time. Free text entry bypasses this control. It makes accurate tracking and root cause analysis impossible. Structured drop-down menus, specifically those aligned to standards like ISO 14224, guarantee the data is immediately quantifiable. In the oil and gas sector, this constraint is absolute. The system physically blocks a work order from reaching technical closure unless both a specific failure mode and a cause code are populated. In utilities, a hard logical check prevents a technician from logging an outage start time with a value later than its end time. The software simply rejects the physical keystroke. The configuration and enforcement of these point-of-creation rules belong exclusively to the CMMS administrator. Think of entry rules as preventive maintenance for your database. Skipping these initial controls guarantees an exponential multiplication of errors downstream. But data that successfully passes through the gateway does not stay perfect in a vacuum. Plant configurations update. Physical equipment is modified on the floor. Over months and years of operation, technician behavior drifts away from established standards. This requires data health criteria. This is continuous condition monitoring for your operational database, functioning like a radar tracking the stored data. The radar sweeps the system, checking specific dimensions: complete, accurate, consistent, and completely unique. It verifies that 95% of corrective work orders maintain valid failure codes and calculates PM compliance strictly on valid records, isolating corrupted ones. This provides a direct contrast in architecture. Entry rules are preventive controls applied at creation to block garbage data. Health criteria are diagnostic checks applied after the data exists to prevent false insights. Because health criteria measure operational reality, they are owned by the asset and reliability teams, not the CMMS administrator. If an organization fails to balance these two systems, the database collapses. Missing entry rules force endless daily firefighting. Missing health checks allow silent decay to poison executive reports. By layering both systems, gateways at the door and radar in the vault, an organization ensures its data accurately reflects the physical assets, supporting true root cause analysis. This conceptual blueprint is already translated into practical code across major enterprise software platforms. Take master data control. To prevent duplicate assets and enforce naming hierarchies, the software strictly limits asset creation. SAP PM uses authorization objects. Maximo relies on security groups. Infor EAM applies user roles. For work order closeout, SAP's catalog profiles and Maximo's conditional status rules physically halt the workflow until labor hours and notes are provided. Failure codes are locked into rigid drop-down structures. This removes the ability for a technician to select miscellaneous or other, preserving data for accurate trending. Furthermore, PM data rules strictly enforce task standardization. Instead of manual copy-paste entries, the system ensures the exact same interval and job plan is applied consistently across identical assets. Finally, data health KPIs act on the output. When invalid data is detected, the system automatically recalculates or completely excludes the bad records from executive dashboards. The software nomenclature changes depending on whether you deploy SAP, Maximo, or Infor, but the architectural mandate remains identical: force structural discipline over human preference. A perfectly engineered system, equipped with tight gateways and continuous radar, will still fail if the human element is undefined. This requires a rigid RACI framework. It explicitly separates the person who owns the software configuration from the person who owns the reality of the plant floor. The framework operates on an unbreakable rule: there can be only one single accountable person for any given process. The exact sphere of the CMMS administrator is the software. They own the system configuration, they build the gateways, and they manage the change control process. The asset owner is accountable for operational truth. They define the accuracy of the asset hierarchy and dictate the physical meaning of the data. The reliability engineer owns the insight. They operate the diagnostic radar and translate data health metrics into active maintenance strategy. The architecture is now complete. Hard-coded entry rules feed clean data into continuous health monitors, and every node is supervised by clearly separated human owners. This leads to a definitive rule of asset management: you do not manage data with reports. Effective governance requires hard-coded